Hi everyone, I'm Niklas from Stockholm, Sweden. In this project I have studied mathematical chaos in equations that are closely related to how black holes can be described in string theory. Chaos in this sense means that some systems are extremely sensitive to initial conditions and therefore completely unpredictable on long timescales. Small perturbations grow exponentially, which makes it possible to determine exactly how chaotic a system of equations is. The differential equations I have studied is a toy model that describes the dynamics of two so-called d-particles in a classical manner. The awesome thing about d-particles is that if you have a large number of them, a black hole is formed, the gravity of which is directly related to the chaos in the dynamics of the fundamentally quantum mechanical d-particles. Thus, d-particles are a promising approach to unifying quantum mechanics and general relativity into a theory of quantum gravity, which is ultimately one of the most important goals of modern physics. By using and comparing two different numerical methods, I calculated how chaotic this system of d-particles is, and how that chaos depends on the energy and the initial conditions. Here you see part of my results. On the x-axis we have the initial position of one of the particles, and on the y-axis the initial position of the other one. Units are irrelevant as they are arbitrary. The color in every point on this graph represents the amount of chaos that initial configuration produces according to this scale. Interestingly, there appears to be obvious patterns such as these curves, which haven't been observed previously. Understanding exactly why they appear and what they imply about the nature of black holes is a project for the future, but hopefully my results can be used to better understand how d-particles just might eventually give us a theory of everything.